Welcome back to Introduction to Chemical Engineering. In the first part of the chemistry modules, we talked about fuel, we talked about gasoline, diesel, we talked a little bit about where we get the gasoline and diesel from, and so forth. We're going to switch now and talk about another product of the products in chemistry, light-sensitive materials, camera film, the traditional silver halides, or these digital camera films and so forth. And so that's our objective here. So we're going to look at some sensors. We're going to ask the question, what are some of the chemical and physical principles behind the sensors and the role of the engineering in making those sensors possible. So we talk about light-sensitive materials. The light-sensitive materials we're going to talk about, I divide them broadly into two categories. One is we call the traditional camera film, and I know you don't, it's getting less and less, it's getting much less common now to find camera films, though they do exist. And then, of course, the digital camera, which is not a film as such, but a light-sensitive material which is used to create the film that we actually see, a hard copy, if you will. We'll talk about both. Before we get into the specifics, let's talk a little bit about light. What is light, and what we are able to see around us, right? The visible light that we are able to see around us, white light as it is really, one way you can look at is white light is a mixture of several different colors. And if you imagine, you can put a violet, indigo, blue, green, yellow, orange, and red. If you mix them, you'll essentially get white. Or you can imagine if you take white light and say take away one of the components, you'll have a mixture of the other six, and so forth. Right? So the question is, so what are these different colors? They have different wavelengths and therefore different energies. And so white light is a mixture of light of different wavelengths and different energies. And as you can imagine, it impacts, it goes to the, as to why we have different energies and different wavelengths. It goes to an understanding of the electronic structure and therefore the chemistry of the materials that are actually used to make these materials of different color and so forth. So for white light, for example, these things go from approximately 400 nanometers to about 700 nanometers in the red. So the color that we see are the colors that are actually reflected by the object that some light is incident on. So so what we see are the wavelengths that are reflected and seen by our eye. So here's an example. OpenStax College is a great website for textbooks in physics, chemistry, and math. I'll ask you to check it out. This is from the website. So here, for example, you have these different wavelengths of light hitting a surface, and if only the blue gets reflected, it looks like it looks blue to us. Well, here it looks red. And a white object, for example, will reflect red light, and a black object will reflect nothing. So black is the absence of any of the reflected light at all. So that's the nature of the light. And so you can imagine you can take three primary colors, for example, and mix them up and get different colors. Example here is you mix red and the green and you get yellow, you mix red and blue, you get magenta, and so forth. So you can imagine the different colors can be obtained by mixing actually three primary colors. In fact, if you go back and look at the color printers, if you have at home, or color laser printer or just regular color printer, they will have three cartridges, if you will, and there's three primary colors. And by mixing them up in different proportions, you get all kinds of magnificent looking colors. That's something to imagine, right? And so colors. So as I mentioned earlier, what we see as yellow or green or red and so forth is ultimately related to the electronic structure, or it is related to the energy level of the electron that are actually released, that we were able to see when light is incident on those materials. So depending on what the electronic transitions are, essentially determines what type of color something actually might have. To put it very, very simply. So you can imagine that different atoms, they have a nucleus, they have these electrons at different energy levels, and depending on the wavelength of the photon that are emitted because of the electrons transitioning between these different energy levels, you see different colors. So you can imagine, therefore, chemists can actually synthesize materials they're sensitive to different colors, or emitting different colors, and so forth. And so color is a very, very good example of the chemistry in action, where you are designing the chemistry to be able to see colors or exhibit different colors. And that's the reason why the chemistry is so important in terms of whether we're looking at silver halide films, which have a different means of getting the colors, or the digital film that we are familiar with, which we'll talk about in the next video.